Hey Becca, what are we learning today?
Today, we are taking derivatives of exponential functions. Consider the function f of x equals e to the x. The derivative of this function is very simple. It is simply exactly the function itself, e to the x. So this function and its derivative are equal. Now consider the function f of x equals e to the u, where u is some function of x. The derivative of e to the u is simple, but there's a little catch. It's exactly the function e to the u, but we must multiply by the derivative of u with respect to x. I wrote the derivative formulas at the top of the screen so that we can use them for reference in the next few examples. The first example, f of x equals e to the x squared. Our u term is this function of x, so u equals x squared. When we take the derivative of e to the u, we repeat e to the u, which is x squared, but we have to multiply by the derivative of u with respect to x. U prime, with using the power rule, we bring the 2 down, is just 2x. So we're going to multiply e to the x squared times 2x, and combining 2x e to the x squared is our derivative of e to the x squared. This next example, f of x equals e to the ln x. Now e and ln will cancel, and this will just equal x. But I want to go through this derivative using the exponential formula rather than just using the power rule, and we'll verify that we get the same answer. So in this exponential, our exponent is our u term, u equals ln x. The derivative of an exponential is itself e to the ln x, but we have to multiply by the derivative of u. The derivative of ln x is 1 over x. So we're going to multiply this term by 1 over x. So we get e to the ln x over x. That's our derivative of e to the ln x. But e to the ln x equals x when you cancel the e and the natural log. So we can do the same thing here. The e and the natural log cancel. We'll just be left with x over x, which reduces to 1, and 1 is the derivative of x. So we verified that the exponential derivative is in fact this formula up here. I have 2 more examples to go through with you today. F of x equals 7e to the x squared over 7. When we take the derivative of this exponential term, the 7 in front is a constant, and it's carried down into the derivative as a multiple. Our u is the exponent, u equals x squared over 7. When we take the derivative of this exponential term, we repeat the exponential term, x squared over 7, but we must multiply by the derivative of u. What's the derivative of our u term? We can use the power rule. We bring down the 2 over 7, x to the first power. So that's going to be what we multiply our exponential term by, 2 over 7x. And if we reduce this, our 7's cancel, and we're just left with 2x e to the x squared over 7. That's our derivative of our function. One more example, e to the 3x squared minus 9x plus 8. Our u term is this entire exponent, 3x squared minus 9x plus 8. The derivative of an exponential is itself, so we repeat it, but we must multiply by the derivative of u with respect to x. If we use the power rule, bring the 2 down, 6x minus 9. So our whole exponential term is being multiplied by 6x minus 9. And we're going to leave our answer in this form because there's no point in reducing this. It's in its most reduced form. It looks ugly, but it's still an acceptable answer as the derivative of our function.
Thanks for watching my video on derivatives of exponential functions. I hope you found it helpful, and if you did, give it 2 thumbs up, and subscribe because I'm posting new videos every Monday and Thursday. See you then!